This trial was devised at the last minute. It was supposed to be a fertility trial, but we didn't receive the products in a timely manner. So on June 6, we seeded a trial that was hastily designed to fit the area that had already been flagged. The treatments were of interest to us, but I honestly doubt we would have received outside funding for this demonstration. Since the canola was getting into the ground late, maturity was potentially going to be an issue, and that is certainly proving to be true since the beginning of this summer has been relatively cool and wet.
I'm sure the hail didn't help either.
True, but fortunately the canola was at a young stage when we received hail on June 23rd. To hasten maturity, we looked at increasing seeding rate and decreasing nitrogen rate. The seeding rates were 2, 4, and 6 pounds per acre. For each of these seeding rates, we evaluated 60, 90, and 120 pounds of actual nitrogen per acre. We also evaluated 13 pounds of nitrogen per acre for the 2 and 6 pound seeding rates. Couldn't do it for the 4 pound rate because, well, there just wasn't enough room. Seeding rates of 2, 4, and 6 pounds per acre resulted in emergence rates of 36, 60, and 80 plants per meter squared, respectively. Generally, if you have over 40 plants per meter squared, your crop really shouldn't suffer any yield loss because the canola is a plastic plant. In other words, it's able to compensate for low emergence rates by branching.
Here's a plant taken from the high seeding rate, and here's a plant taken from the low seeding rate. You can see there's much more branches with the lower seeding rate as canola has more space to grow into. Of course, maturity will also be delayed with the lower seeding rate, as it will be taking more time for the secondary branches to mature the seed. Let's see how the maturity and yield differed among treatments.
Before we get there, let me show you how the different seeding rates developed through the summer. These are the 3 seeding rates on June 21st for the 60-pound rate of nitrogen. You can definitely see a difference in plant populations. Ideally, we would like to see a plant population above 40 plants per meter squared to avoid yield loss when seeding with a conventional drill like our Seedmaster. In the future, we hope to be involved in a field-scale demonstration to determine if low seeding rates suffer less yield loss when plants are evenly spaced by a planter compared to the more variable seed placement achieved with a conventional seeder. Anyway, here are those same plots from our trial on July 6. You can see stand establishment differences are still apparent. Here are the plots on July 18th. You can see flowering seems to be occurring earlier for the higher seeding rate. Here we are on August 12th. You can see that the low seeding rate still has some flowers. This was even more apparent if we look at the seeding rate with 120 pounds of nitrogen per acre. Low seeding rate and higher nitrogen is going to delay maturity. Okay, let's dig into the data. The top table is looking at the main effects of increasing nitrogen rate, and the bottom table is looking at the main effects of increasing seeding rate. Here is the yield response to increasing nitrogen. There was a fair bit of residual soil nitrogen at this location, 56 pounds per acre in the top 12 inches to be precise. So with these nitrogen rates, we are definitely at the end of the nitrogen response curve. Here is the yield response to increasing seeding rate. A seeding rate of 2 pounds per acre wasn't quite enough to maximize our yield. Increasing the seeding rate to 4 pounds per acre gave us another 4 bushels per acre. For an economic comparison, I'm going to use the values with the Saskatchewan 2022 Crop Planning Guide. With canola being $17 per bushel, here are the gross returns, which are simply bushels per acre times dollars per bushel. If we assume $1.33 per pound of nitrogen, then here are the nitrogen costs associated with the 3 rates of nitrogen. To compare the economics between the rates of nitrogen, we need to look at the gross revenue minus the cost of nitrogen. The rate of nitrogen that generated the most revenue in this study was 90 pounds per acre. Let's look at the seeding rate data now. If we assume a seed cost of $15 per pound, then here are the seed costs associated with the different seeding rates. In turn, here are the gross revenues minus the cost of seed for each seeding rate. It would appear that 4 pounds of seed per acre gave us the best return. So our best economic return at this site was with 4 pounds per acre of seed with 90 pounds per acre of nitrogen. But we seeded this trial on June 6, which is a little bit on the late side. We might be concerned about maturity and are wondering if we should be holding back on nitrogen or increasing seeding rate to hasten maturity. To get a sense of this difference in maturity, we took the seed moisture at harvest on September 22nd. Plots at that time were direct combined. However, I made a mistake though and applied Reglone to the trial 6 days before harvest. This probably narrowed the range of seed moisture between the treatments. But there was still a seed moisture difference between treatments at harvest. Here are the moisture differences between the rates of nitrogen. If we had cut back nitrogen from 90 to 60 pounds of nitrogen per acre, we really didn't affect maturity much. If we had increased the nitrogen rate from 90 to 120 pounds per acre, we would have delayed maturity. But the seed moisture is only 0.65% greater. This probably only represents a delay of a day or two. So 90 pounds of nitrogen per acre was the best rate of nitrogen in this study. Differences in seed moisture at harvest were a little more pronounced with the seeding rate data. Seed moisture was 1.38% higher with the 2 pound per acre seeding rate compared to the 4 pound per acre rate. If I hadn't applied Reglone, the difference would probably have been a little greater. So in this study, the seeding rate of 4 pounds per acre was best, as we maximized our economic returns and hastened maturity by potentially a few days. I recall being told once that increasing seeding rate could hasten maturity by 3 days, and that seems plausible based on the results of this study. Of course, the number of days maturity is hastened is really going to depend on the kind of fall harvest we have. If drying conditions are good, then differences seeding rate makes is going to be relatively small compared to a harvest when drying conditions are poor. Drying conditions at harvest in this study were pretty good. Again, this study was just thrown together at the last minute, but it was something that I wanted to compare for myself. When seeding late, you might want to hold back on the nitrogen rate a little bit to possibly hasten maturity, and probably mostly because you've got a lower yield potential when seeding late. But you probably only need to reduce N rates by maybe 10%. Well, that's it for me. Hope you found this of interest.